Okay, hi. In CSE 174, the activity you're going to do the most is write Java programs. You're going to write programs. You're going to run those programs. You'll run the program. Maybe you'll find a mistake. You'll go back and make changes. You'll run the program again until you're happy with the results. Most of the time when you're doing your programming, you're going to use what's called an IDE, an integrated development environment, that just puts all the tools that you need into one program. And the program we're going to be using this semester is called jGRASP. It is one of many IDEs out there. But you do not need an IDE in order to do programming. An IDE just brings together a bunch of different tools. That's what the I is in IDE. It's the integrated part. You do not need an IDE when you're programming. It's just a convenient thing to have. The programming process really just involves 3 tools, and you can do all of these. And what I want to show you is how you can actually program in Java without using an IDE. And in doing this, hopefully it will kind of help you understand the main tools that we use when we are programming, and it will help you understand better and appreciate more what the IDE is. So one of the 3 tools that you need is a text editor. And whether you're using a Windows machine or a Mac machine, it's going to have some kind of text editor built into it. I should say install in it. If you're using a Mac, I believe TextEdit is the text editor that's already there. If you're using Windows, then Notepad is the text editor. Text editor is just a bare bones editor for typing in text. It's not a word processor. It's not meant to allow you to use different fonts or anything like that. It's just a place to type text. And you don't need any special text editor in order to write Java programs. So I'm going to use the most bare bones text editor of all on Windows, and that is just Notepad. You can see I also have Notepad++ up here. Notepad++ is a free text editor that you can download that it just adds features on to what you would normally find in Notepad. But we're really not going to use either of these this semester. I'll sometimes open up files in Notepad++ just to demonstrate things, but I want to show you the most bare bones Windows text editor and how we can use it to write a Java program. So I'm looking at my Notepad window here, and I'm just going to type some text that I know will make a working Java program. So probably the program we almost always write first when writing a program is hello world. So I'm going to make a class called hello, and in it put a method. And right now, at this point in the course, you're not expected to understand what the code is that I am typing. Right now, I want you to just see what the process is. And so far, what you should see is that I'm using a text editor to write some Java code. The Java programming language, you're going to learn about 20 Java keywords this semester, and you've just seen 1, 2, 3 of them, 4 of them, public, class, static, and void. Oh, and string. You're going to see string as well. Not really a keyword, it's a class name, but the number of commands you're going to learn in Java is a very, very, very short list. It's putting them together in meaningful ways that is the fun challenge of a programming course. So I'm writing a method that I just want to print hello world to the screen. So I can do that like this. And that's it. That by itself is a working, should be code that can be turned into a working program. Now this, I'm going to save it. I've got this folder over here called Java Demo. I will save it in my Java Demo folder so that we can kind of keep an eye on the process here. And I'm going to save it as a .java file. There is a rule that you'll notice here that I named, it says public class hello. Whatever I put after class, that has to also be the name of the file, and then I throw a .java after it. So public class hello means the name of my file has to be excuse me, hello.java. And Java is case sensitive, so when we create classes, we tend to make this first letter uppercase. So I'm going to make sure that the H in my hello.java is uppercase as well. And now I can come over here and look, and I can see there's hello.java. This is just a text file. There is nothing special about this. I can open it in Notepad. Here I can open it in Notepad++. Notepad++ does some coloring of the text, but it is all the same text. Okay. So I said there are 3 pieces that you need in the programming process. One of them is a text editor to create a file like this. The next one that you need is called a compiler. And a compiler, see, here's the thing. Computers do not understand Java. My Windows machine does not understand Java. Java is a programming language that humans wrote, and in order for a computer to be able to run the code, that language needs to be converted into a binary that the computer will understand. And in Java, that's a 2-step process. And the first step is compiling the code that I write. Compiling translates, takes this and turns it into something closer to what the computer understands. Java is considered a high-level programming language. You can look at this and kind of understand some of what it says. It's meant to be looked at and written by humans. It's got commands like print and print line. It's got words like in and out. Out refers to the screen. In refers to the keyboard. You should be able to look at this and recognize it. You might not know what all the words mean, but a lot of that you can look at and say, oh, those are words. I understand those. But the computer doesn't understand those. So step 2 in our process. Step 1 was write this Java code and save it in a file. Step 2 is to convert that code into what is known as Java bytecode, and that requires a separate tool. That tool is called the Java compiler, and I can find that the Java compiler is actually on my machine somewhere. And the name of that compiler, let me see if I can find it on here for you. I have various compilers stored on here. I'm just going to tell you that there's a compiler called Java C. The C is for compiler, and if I go to the command line, which I can do, let's do that here. This is the command line where I can type various commands, and one of the commands I can type is Java C. Now this works because the Java compiler it's part of the Java development kit, and I have that installed on my computer. All that matters right now is that you know that there is this thing called a compiler, and the Java compiler takes code that I've written and turns it into what's known as Java bytecode. So if I just type Java C all by itself, it gives me a list of different ways that I can use Java C. For example, you can see that one way that I can run it is to include version after I type Java C. So I type Java C -version, and it will tell me which version. I'm using version 8 of the Java compiler. I also have version 14 installed on my computer. Different versions of Java require different compilers, but we'll probably use one of the later versions of the Java language, which involves using the corresponding Java compiler, which you'll get installed on your machine. It's a very easy process. Once you have the purpose of this Java compiler is to take this code that I've written and turn it into Java bytecode. So recall that I have in this Java demo folder hello.java. Now I'm going to run the Java compiler. Now I need to navigate into my Java demo folder. Like right now, so with CD desktop, I can move to the desktop, and I can list what's on my desktop. That's from the command line. And look, it says on my desktop I have folders. This D means directory or folder. It says I have a folder named Java Demo and a folder named Temp, and that corresponds to these right here. I'm going to change the directory into Java Demo, so I'm going to CD Java Demo. And now if I list what's there, I will see, oh, I have a file called hello.java. The length of that file is 105 bytes. That is simply telling me that I have this file right here. Okay. So what is it I wanted to do? I wanted to convert this file into a Java bytecode file. And I'm going to do that with the Java compiler. So I'm just going to call javac and the name of my file. I'm saying that I want to compile hello.java. And when I do that, if I have mistakes in it, it's going to let me know that I have a mistake in it. And it is telling me I'm missing something. And the reason I'm missing it is I should have typed something here, which is what can happen if I'm talking and typing code at the same time. I need a variable name in here. So public static void main string args, and you'll hear that over and over again this semester. So I made a change to this. I saved it. So what happened here is I used the Java compiler and said compile hello.java. I got an error message that says you did something that doesn't fit the rules for proper Java, and so the compiler says I cannot make your bytecode file for you yet. And I can look, and if I look in this folder, I can see there's hello.java still sitting there. If I had successfully compiled, we would see one more file here. Hopefully now I'm going to try to compile again. And hopefully this time, since I've fixed that error in my code, remember I typed something right here, hopefully I've fixed that. Okay, I did not get any error messages this time, so I can go and look, and I will see that in addition to my hello.java that I typed, I now have this hello.class, which was created by the compiler. This is not meant for human eyes. This is meant to be run. If I can look at this, I can look, let's open it in Notepad++ and see what a .class file looks like. It looks like a garbled mess. Okay, it does not, you can see some things in here that you might recognize, but you see a lot of symbols that don't make sense. I can see my hello world, look at that, there's my hello world. And see some other things that look like words that I recognize. But the .class file is not meant for humans to read, it's meant for a machine to read. So we've seen 2 out of 3 steps. Step 1, we used a text editor to type Java source code, we call it. We typed Java source code just using a text editor and save that file. Step 2, we compiled hello.java, and that in turn created hello.class. If we have errors, we stop, we fix the source code, and then we try to compile again, and now we have that. Step 3 is to actually run the program. And to run the program, we're going to run the code that's in this file. So we write this file, the compiler creates this file, and then we run the code here by using what's called the Java virtual machine. The Java virtual machine is something we call using just Java. And we put the name of the class. So I didn't put hello.class. And this is not even a detail you have to remember. What I want, though, is for you to see that I wrote the code, I compiled the code, and now I'm going to run the code that's in the bytecode file, the file that ends in .class. What should happen at this point is the code that says print hello world should be executed. When I press enter, I get hello world. Okay, now if I want to make changes, like for example, see where it says hello world and the H is in lowercase. What if I wanted it to be in uppercase? Well, I go back to my code, and I just have to remember the 3 steps in the process. I change the lowercase h to an uppercase h, and I'll save it. Then I go back to my compiler, javac, and recompile it. And then I run the program again. And now I can see the H is now in uppercase. Those are the 3 steps to the process. So we write the code, we compile the code, and then we run the code. And the way Java works is that this code, the .class file, can really be run by anybody who has a Java virtual machine on their computer. So if you wrote something and you wanted to share it with somebody, technically you could just supply them with the .class file. And as long as they have the Java virtual machine installed on their computer, and it doesn't matter if their computer is a Windows computer, Mac, or Linux, you can run what's in a class file as long as you have a Java virtual machine. And that Java virtual machine does the job of taking the bytecode and turning it into machine level binary that your computer actually understands and can execute. Okay, so those are the 3 steps. Now I said that when we use jGRASP, that jGRASP is an IDE that integrates all of those tools together. So let me show you that I can do all of the same things that I just did, but I can do them here instead. So in jGRASP, you would create a new file. You would, let me blow up the font there a little bit. There we go. I would type my program in. Let's call this one done. You'll notice right away that the text, so that, remember the 3 tools, an editor, a compiler, and then a way to run the program. So right now I'm typing text in the editor. You can see that the text editor does some color coding to make certain words stand out in certain ways. And that's it. So I've written it. I'm going to save it. Let's save it to the desktop. We'll save it to the Java demo folder. Notice that the editor for jGRASP is a bit smarter when I save it, and it looks and it says, oh, you named your class done. I bet you want to name your file done.java. And so it's already filled that in for me. So I'll save it. If I look in the folder, I can see that here is done.java. Now I need to compile the file. I could come over here and compile it, but I'm trying to use jGRASP right now. If in jGRASP, instead of calling it compile, it's called build. And Control B will compile it. I'm just going to click it here. And down here I can see that it says it's compiling and the operation is complete. If it's really complete, then what do you expect to see in that folder on my desktop? Can you imagine? Like, what would be the name of the file that you would expect to see? So go ahead and make your guess, and I will show you. Hopefully you guessed done.class. I named my class done, which means I need to save it in a file named done.java. And then the compiler, which I ran when I clicked in the menu here, created a file named done.class. And now that I've edited the file and saved it and compiled the file, now I'm ready to run the file. And in jGRASP, the keyboard shortcut for running is Control-R, or if you're using a Mac, Command-R. And there it is. I run the program, and right down here it gives me the results. Now you might think that jGRASP must therefore have a compiler built into it and a Java virtual machine built into it. It does not. All it does is it uses an existing compiler. So somewhere on my machine, Java-C has to exist so that when I do this and click compile, it's not really technically jGRASP that's compiling it. Rather, jGRASP is calling Java-C and saying, hey, Java compiler, go do your work. And then jGRASP just reports back the results. Same thing when I actually run the program. jGRASP is not really running it. It's calling the Java virtual machine to do the job of running it, and it's simply showing the results right here. So all that jGRASP really does is gives us an editor and a compiler and a Java virtual machine that can run the bytecode. This is the source code. This file here is the source code. Compiling produces the bytecode in this file right here. And then running, when I click run, it runs the code in here. So if I skip a step, for example, let's say I create a new file. Let's just copy and paste this. And call this new. Oh, here I can use keyboard shortcuts. Control N for new. Let's call this one incomplete. And I'll save it. It's going to ask if I want to call it incomplete.java. I do. And now I'm going to go to run. And I should get an error message. Oh, I didn't get an error message because jGRASP actually did a favor for me. It said, well, if you want to run it, one of the things I'm going to need to do for you first is to compile it. And so that's one of the nice things with jGRASP, actually, is that it knows what it is you want to do and anticipates. It says, if you want to run this, then you're going to have to compile it first. So let me compile it for you. And you can see there's incomplete class right there, which means it must be right here as well. Okay, so I was going to show you that if I skipped the compile step, it wouldn't work. But actually, it works just fine here. What wouldn't work is if I had done that without the IDE. So for example, if I create a brand new file, let's call this bad, and just say this won't run. And let's save it as bad.java. And if I go to the command line, I can look and see, if I list all the files, I can see there's done.java, done.class, hello.java, hello.class, incomplete.java, incomplete.class. But I have bad.java and I don't have bad.class. That means if I were to say java bad, I should get an error message. Could not find or load main class bad. It means I have not made my class file yet. So what am I missing? The compiler. And now that I've run the compiler, if I list my files again, I can see, oh, there's bad.class. And now I can run bad. And there it is. Oh, and it says this won't run. But it does run because I fixed it. So those are the steps. Write it in an editor. You write source code in an editor. You use a compiler to turn source code into bytecode. And then you use a Java virtual machine to run that bytecode on your computer.